world of AI. How do you build something you can actually trust? How do you go from a single, simple line of code to a massive system that's reliable, predictable, and, well, accountable? Today, we are diving deep into exactly that. Welcome to the Inveos channel. We're all about giving you practical strategies to build smarter systems and scale your business. And today's topic is a big one. We're going to take a journey from a single Python function all the way to system-wide integrity. And trust me, it's a lot more straightforward than you might think.
So here's the game plan. We are about to break down one of the most fundamental techniques for building AI agents that you can actually deploy in production without losing sleep. First, we'll look at what an AI tool even is. Then we'll get into the code and see how to define it with a really simple contract. After that, we'll connect the dots to see why this is the absolute key to making your agents auditable. We'll zoom out to system-level accountability, and then we'll wrap up with how you can start building with Google's Agent Development Kit, the ADK, like today.
Okay, so where does a trustworthy AI even begin? It's not with some giant, scary, complex model. Nope. It all starts with a single foundational building block. Its very first tool. See, in the world of modern AI agents, and especially if you're using Google's ADK, an agent is really only as good as the tools you give it. Think of tools as how an agent sees and interacts with the world. It could be reading a file, calling an API, doing some math. They literally define everything the agent can do. So, how do we make these powerful tools? You might be picturing some crazy complex framework, but the answer is actually incredibly simple. It's all about turning a regular, everyday Python function into a crystal clear, powerful instruction for an AI. And this quote from the new stack really nails it. There's no secret sauce here, no proprietary magic. We're just using standard Python best practices, functions, type hints, and docstrings. The ADK framework is just really smart about using these things to tell the large language model, the LLM, what to do and when to do it. And here is a perfect, bite-sized example straight from the ADK tutorial. It's just a function called greetUser. It takes a string called name, and it returns a dictionary. It's clean, it's simple. Honestly, any Python developer has written something like this 1,000 times. But to an AI agent, this is a very specific, actionable skill it now has. Now here is the part that is a major mind shift. That little bit of text in the triple quotes, the docstring, it's not just for your developer friends anymore. For an AI agent, your docstring is the API documentation. It's literally how the LLM figures out what the tool is for and decides if it's the right one for the job at hand. So every single part of this function creates a clear contract with the AI. The function name, that tells the agent what it's called. The type hints, they say, hey, I need exactly this kind of data to work. The docstring explains its purpose, its why, and the return value defines what the agent gets back. This whole contract just gets rid of any guesswork. But look, this simple contract isn't just about writing nice, clean code. It is your absolute first and most important line of defense against building a chaotic, unpredictable AI. This is the bridge from your code to being able to actually audit what your system is doing. I mean, just think about the alternative for a second. You could build a monolithic agent, right? One giant prompt that tries to do everything. It's a total black box. And when it messes up, and it will, good luck figuring out which part of your 100-line instruction went wrong. Compare that to a tool-based agent. Every single action is a specific function call. The agent's thought process becomes this traceable sequence of tools it used. If something breaks, you don't debug a prompt. You can go right to the exact tool that failed and see why. For reliability in production, this is an absolute game changer. And this whole idea of traceable actions becomes even more critical as we zoom out. We're not just building single agents anymore. We're building entire systems of agents that have to work together. And at that point, the goal isn't just debugging one agent. It's about achieving accountability across the entire system. So what does happen when these agents start teaming up? Well, the complexity doesn't just add up, it multiplies. I mean, just look at this. You can have multiple agents, each running its own logic, all talking to each other through some shared knowledge base. Now, if the final result is wrong, where did the mistake happen? Was it agent 1's logic? Was it an action agent 2 took? Or did they just misunderstand each other? Without those clear, audible tool contracts we set up from the beginning, finding that single point of failure becomes a total nightmare. In fact, AI safety researchers have pointed these out as the key risks in these big agentic systems. You've got opaque reasoning. You have no idea how it made a decision. Unchecked autonomy, where the agent just does stuff without review.
Planning fragility, where one tiny error snowballs into a massive system failure. And of course, a total lack of an accountability infrastructure. No logs, no trails, nothing. That simple, well-defined Python tool we talked about, it's your foundational defense against every single one of these risks, just by creating a clear, auditable trail.
Okay, so this all sounds great in theory, but how do you actually put it into practice? Let's bring it all home and talk about your first actionable step for building better, more robust AI agents using the ADK.
First things first, do not try to build a massive multi-agent system on day one. Please start simple. Create a project and define just one tool, a single Python function with a good name, clear type hints, and a really descriptive docstring. Then just use the add k run command to open up a little chat with your agent. Talk to it. See if it uses your tool correctly. And once that works, add a second tool and watch how the LLM decides between the two. This step-by-step process is how you build up complex, reliable systems with confidence.
At the end of the day, an agent is really defined by its tools. There are the senses it uses to understand the world and the hands it uses to interact with it. They define its capabilities, its limits, and even its character. So the real question is, what are you going to empower your agents to do?